guys, welcome back to the channel. My name is Jag, and in today's class we are going to continue with our grade 10 math content, and this is going to be graphing the quadratic transformations part 1, and this will be maybe like a two-part series here, and then we can always do a video on basically just reviewing everything all together. Alright, so with that, let's get started. So let's take a look at basically this question here from the textbook. It says to sketch the graphs of these three quadratic relations on the same set of axes. Okay, so first I'm going to just show you. So I guess we'll put example here. Okay, I'm going to actually show you how to draw the y equals x squared curve. Okay, now this is the standard parent quadratic equation, so you should know how to draw it. Okay, so I'm going to put some values here. Okay, so -1, -2, and so on and so forth. Okay, so I would put the actual numbers up to 4. Okay, the standard quadratic equation is the y equals x squared curve. I have a point, it's at 0, 0. The second point is going to be at 1, 1, and the third point is 2 and 4. Okay, now it does follow the step pattern rule, and we'll go through that actually afterwards. So I want to make sure everyone is just memorizing these points here. Remember, on the other side of the quadratic equation, it is going to be symmetrical. So it's going to be -1 and 1, -2 and 4. So I can see that I have 5 points on my quadratic equation. So we're going to just join these points together here. Okay, and it looks like this. Make sure you are always putting the arrows, okay, on both sides of the parabola. And this is the y equals x squared curve. Okay, everyone sees that? So again, we are just memorizing these points because the parent function always has to be graphed out before you show any of the transformations. Alright, so I'm going to actually just use something simple so we can see how to do this. So say I'm graphing the y equals 2x squared curve. Okay, now the 2 value here is basically the value of a, and I can see because the value of a is actually greater than 1. Okay, and we will go through all of these transformations again. All right, the value of a is greater than 1, so this is actually a vertical stretch. Okay, and a vertical stretch basically means I am taking the parabola, I'm stretching it out, and you'll see that the graph is actually much thinner. Okay, so what we're going to do is take this value of y, okay, which is 1 at this point, and I'm just going to do 1 times 2, which is equal to 2. Okay, so this point is going to move up to 2, so let's put equals 2. Okay, and again, because it's symmetrical on both sides, the value for that's at -1, that's also going to go up to 2. Does everyone see that? So we're taking the y value and you're multiplying it by the value of a that you see in the equation. Okay, and the next one, so I'm just going to move it up. This is at 0.8. Okay, so if I look at the next point, the y value it's at is at 4. So you're going to do 4 times 2, which is equal to 8. Okay, so the point is at 4 now, and I'm just going to move that point up to 8. Okay, so I have it right here. And the same thing on the other side as well. Okay, so I can see I have some points here. I'm going to join the points together like this. Okay, does everyone see that? So you can see that second graph that we drew out is a vertical stretch, okay? And it's basically stretched out, and the graph is going to be much thinner than the parent function, which was the y equals x squared curve, okay? And so this is our equation. I'm going to put it right here. This is 2x squared. All right, does everyone see that? So even if there's a negative sign in front, okay, that's not going to make a difference, okay? So if it was say y equals -2x squared, okay, the negative sign just means that the parabola is opening downwards, okay, but the value of a is still equal to 2, okay, which means that the parabola is still a vertical stretch. Okay, this is not like the value of a is -2 and now it's a compression. Okay, so don't get confused with that. Okay, so with that, let's try an example where we are using a fraction as the a value. Okay, so I'm going to just take this off. Okay, and some of the questions will tell you okay, to actually graph it on the same set of axes, just so you can see the vertical stretch or the vertical compression. Okay, so we're gonna try like a really simple one. So let's try graphing the y equals 1/2 x squared curve. Okay, and this time the value of a in front of x squared is a fraction. Okay, so I'm going to put the value of a is less than 1 because 1/2 is equal to 0.5, and whenever the value of a is less than 1, this is a vertical compression. Okay, so I'm going to write it right here. Okay, so we'll put vertical compression. Okay, and let's try graphing it here. Okay, and a vertical compression is just the opposite of a stretch. Okay, so instead of the graph being much thinner now, it's actually going to be much wider, okay, or fatter. So let's try the parent function here. Okay, and put like maybe 4 up to here, okay, on the y-axis. So again, it's at 0, 0, okay, the parent function. It's going to be, the next point is at 1 and 1, and the third point is at 2 and 4. So again, please make sure you are memorizing the parent function for the y equals x squared curve. Whenever you show all the transformations, the teacher is looking for the parent function first, okay? And on the other side, it's going to be the same thing. Okay, so again, because the parabola is symmetrical, I just need to make sure I'm memorizing like one set of points. I don't need to memorize all of them. Okay, another thing to note is when you are graphing the transformations, 3 points on the parabola is enough to actually define the parabola. I don't need to draw out all 5 points every time. Okay, but this is just to show you as a reference. Okay, so this is the y equals x squared curve. Okay, now you notice the value for a is 1/2. So again, I'm going to take this point, the y value is 1, and I'm just going to times it by 1/2. So maybe let's put it on the bottom, okay? So I'm doing 1 times 1/2, which is equal to 1/2 or 0.5, okay? So right now, this point is basically at 1. I'm going to move it down to 0.5. Okay, and the same thing on the other side as well, okay? I'm going to now take this second point, which is 4, and I'm going to do 4 times 1/2. Okay, so you're just basically taking these y values and you're going to multiply it by the value of a. Okay, so this is going to equal to 2. All right, and so what we're doing here is we're going to take this point 4 and it's going to move down to 2 on both sides. Okay, so I'm going to write this on the top here. Okay, so this was the 4 times 1/2, which is equal to 2. Okay, and now you can see as I basically take all these points, the points at the origin, that point is not going to actually change. Okay, so this is what my graph looks like now. Okay, I hope everyone can see that. This is the y equals 1/2 x squared curve. Okay, so I can see again, because this is a vertical compression, think about just like you're squishing something and it's basically getting wider. Okay, and that's the only time it will be wider. Even if it's a fraction, make sure the fraction is actually less than 1. Okay, so what if the fraction was y equals like 3/2 x squared? Okay, now basically just because it's a fraction, this doesn't mean this is a vertical compression. If I do 3 divided by 2, this is 1.5, and the value is greater than 1, so the teacher can try to trick you there. Okay, so don't get fooled. 3/2 is 1.5, it's greater than 1, so this is actually a vertical stretch. Okay, it's not going to be a compression here. Okay, are there any questions so far? Okay, good. So this is all you need to know in terms of the value of a and how to graph out the quadratic transformation. Always start off with the value of a to see if it's a vertical stretch or compression before you start moving the graph around. Okay, so let's go through the next set, okay, of transformation. So I'm going to take this off. Okay, and the next set of transformation is going to be basically whatever the value you have inside the brackets here. So one more time, the question is just saying to sketch the graphs of the 3 quadratic relations on the same set of axes. Okay, so let's try a really simple question. So say I have y equals x plus 3 squared. Okay, And whatever is inside the bracket, so this is going to be a horizontal translation. So remember, the word translation means I'm just taking the whole graph and moving it either to the left or the right, okay? And whenever you do the horizontal translation, I have to make sure I'm changing the sign. So in this case, you see how it says x plus 3, okay? I'm going to change the sign, okay? And when you write out the transformation, this is a horizontal translation. Okay, and it's not plus 3 like it's moving to the right, it's actually moving to the left. So I'm going to put 3 units left. Does everyone see that? Okay, and I have to make sure I change the signs, okay, or the answer is just going to be wrong. So let's try just graphing a sketch here. Okay, so again, so you do notice, okay, that I have to draw out the parent function. And again, the teacher is always going to be looking for that you're able to draw out the parent function and then basically show the transformation of the quadratic, okay? So again, it's at 0, 0, 1 and 1, and 2 and 4. And then I'm just going to make it symmetrical on the other side, okay? This is the y equals x squared curve. So let's join the dots together. So it looks something like this, okay? And what we're going to do now is I'm just going to add a couple of points here, okay? I'm actually just taking the parent function and I'm doing this transformation. I'm just going to move all these points to the left, okay, 3 times. So let's start with the origin here. I'm going 1, 2, 3. So the dot is right here, okay? And one more time, I don't actually have to move all the 5 points. I can only move like 3 points here. Okay, so let's move the next point. So I'm going 1, 2, 3. So the point that was at -1 is now at -4, okay? And for this one, so 1, 2, 3, the point that was at +1, it's moving to the left 3 times and it's now at -2, okay? I'm just gonna add one more point here so we can see it. Okay, we will move the top 2 points as well, okay, just to make the graph accurate. So I'm gonna take this point, it's at -2, and it's moving 1, 2, 3, it's at -5. Okay, and same thing here, I have the +2, moving it 3 times to the left, so 1, 2, 3, and it's going to be at -1, okay? Now if you find it kind of hard to see these points as you're moving the transformations, I would make sure I use maybe different colored pens or like color pencils, and you should actually color code each graph, just as you see in the example within the textbook. Each of the graphs is a different color, just so you don't get confused. Alright, but this is our graph, so I'll make it actually maybe a little bit bigger, like this. Okay, and you should always write the equation, okay, right beside the graph. So this is the y equals x plus 3 squared, okay, graph. And the one that's in the middle, this is the y equals x squared curve of the parabola, and that's just the parent function here, okay? Does everyone see how to do that? Okay, so let's try one more example. Okay, and this time we're gonna just move the graph in the opposite direction. Okay, so I'm gonna just take this off. Okay, and let's try something different. Okay, so we did x plus 3, so let's do x minus 5, okay, squared. Again, I have to make sure when I'm writing the transformation, I have to change the sign here. So if you see x minus 5, again, this is a horizontal. I'm going to put translation. Okay, and which way is this graph moving? So this is -5. That doesn't mean I'm moving to the left. I have to change the sign. I'm moving 5 units right. Okay, so I'm just going to put 5 units right. Okay, and we're just going to graph it on the same set of axes here. Okay, just because I'm moving in the opposite direction, I'm going to take all the points on the parent function and move it 5 units to the right. Okay, so start off with the origin. It's going to move to 5. Okay, then go to the next 2 set of points. Okay, so I'm going 1, 2, 3, 4, 5. So the point that's at 1 is going to be at 6. Okay, this point is at -1, so 1, 2, 3, 4, 5. The point at -1 is moving to 4. Okay, and we're going to do the same thing here. So the point 2 is moving to 7. And you could just do basically the 2 plus 5, which is 7, okay? So I'm basically just taking the x-intercepts or the x values, and you're just adding 5 to that for this transformation, okay? And the same thing here at negative 2, so we'll go 1, 2, 3, 4, 5, so it's negative 2, okay, plus 5, which is positive 3. Okay, and I'm going to join these dots together. And our curve looks like this, okay? But again, make sure you're using actually graph paper when you are graphing this out. Okay, the curve isn't actually wider because I didn't do a vertical stretch or vertical compression here. I'm actually just translating the graph either to the left or the right. Okay, so I'm going to put the equation right here. It's x minus 5 squared. All right, does everyone see how to do that? Okay, so this is the horizontal translation. Whenever you have the value of x inside the brackets here, whether it's x minus 5 or x plus 3, it can actually be any value. Remember, this is a horizontal translation, and I'm just moving the graph either to the left or the right, and don't forget to change the sign, okay, when you're doing this transformation. All right, so you can see this transformation is actually very simple. Okay, it's just you changing the sign. You should also be able to just write out the equation as well. All right. Okay, so that looks good. So if there are no questions, that brings this video to an end. And thank you for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone next time. Thanks. Bye.